In this lecture, we will briefly talk about the ROS logging system and how you can set up log statements in your C++ nodes. In our code thus far, I've only used the standard cout function to print to the terminal we were running our nodes in. Alternatively, ROS has some logging features which allow you to print to the terminal, as well as persist in log files which you can reference later. So here on my Ubuntu machine, the default location for logging is the .ros folder in our home directory. Since it has a dot at the beginning, it is considered a hidden directory. So when we open our File Explorer, we have to either hit the Ctrl-H shortcut or head over to this menu tab and hit Show Hidden Files. Then we can go into the .ros directory. Then we can go into the log folder, and here we have a series of files. These log files get generated pretty much anytime you start a ROS node. So for example, here at the beginning, we see a series of publisher node log files. So I'll click on the last file that says publisher, and we'll go ahead and open it with a text editor. So here on the side, it has this statement. So it says info, it has a timestamp, and it says RCL CPP, signal handler, signum equals 2. You might recognize this as the text that gets shown when we stop our ROS publisher node. So I can actually go ahead and open up our terminal, go into our workspace, source our workspace, and run our publisher node. So at first we see nothing, but as soon as we hit Ctrl-C to stop the node, we actually see this exact same print statement onto the screen that we see here in this log file. So we can create our own log messages within our C++ code, which we can test out using our subscriber node. So I'll go ahead and close these for right now and open up VS Code. So here in our subscriber.cpp file, in our subscriber callback function, we use standard cout to print out the message data. So we can actually go ahead and comment that out and call RCL CPP info instead. This takes in the node logger, which we can get like so, and then take in the data we want to print out. Now, if you notice here, we will get an error. That's because all strings that get passed into this function need to be formatted as a C string, which we can do like so. Now, if I go ahead and save this file with Ctrl-S, I can go ahead and recompile my project. So you can do that by heading over to Terminal and Run Build Task, and I'll be using Ctrl-Shift-B shortcut for the rest of the course. All right, so that's gone ahead and built. So I'll head back over to our terminals, and I will rerun the publisher node. I'll clear the screen. Open up a new terminal, source our workspace, and now run that subscriber node to see the changes we just made. So here we see, instead of just normally printing out hello world, we have this info statement, the timestamp, the name of the node, and then the actual contents we wanted to print. So I can go ahead and stop this with Ctrl-C, and we go ahead and get that signal handler message for this as well. Then I can go back to the log folder and go down to the last subscriber log file. And if I open this up, we see all of these same messages which got printed to our terminal just now, including that last signal handler call. I'll go ahead and close this. So there are different versions of logging. So for example, you can have these general info logs, which will not be highlighted, but there are also warning, error, and debugging logs. We can easily see this in a logging demo example that should have come with your ROS installation. So I'll go ahead and stop our publisher for right now and clear the screen and run ROS2 run logging demo main. So the node starts with just info messages, but eventually we will see some green debug text and periodically see a yellow warning message, as well as red error messages. So for now, I'll go ahead and stop this. And now we can see this particular log file for this node in our log folder. So if I scroll up, it'll be the first one, the logging demo main. And we see all of the same text which just printed to our terminal screen. So hopefully you can see how this debugging functionality can be of use if you have a production system that isn't operating as intended. You can implement logging and check back on the log files from the times of interest. As you may have guessed, in order to use these different log levels, all you have to do is slightly modify the function call you use like so. Then I'll go ahead and save the file and recompile. Alrighty, so that's done. I'll open up my terminal And I'll clear my screen and I will rerun my publisher node. Go ahead and clear this screen. I'll go ahead and raise this tab up a little bit and rerun our subscriber node. So here we see the warning and error messages, but not any debug messages. Go ahead and stop that. Well, we have to initialize a debug state in order to see those messages. One of the ways we can do this is to pass in some arguments when we start the node. So go ahead and clear this, bring back up our subscriber call, and we will add some arguments like so. So here we're setting the log level to debug. So I'm going to go ahead and start this now. And we see tons of green text flood the screen, as well as our warning and error messages. I'll go ahead and stop this just so we can see what's happening. And we get a ton more debug statements. I'll scroll back up. And so here's actually what I'm more interested in. So we see our warning messages in orange with that say hello world, our debug messages in green that say hello world, and our error messages which also say hello world. But then we get tons of extra green text besides what we made debug statements for. Well, if you take a look at the node, this is actually coming from the ROS client libraries and the C++ ROS client libraries, not specifically from our code. So these are general debug statements from the ROS client libraries. If you didn't want all these debug statements, so I'll go ahead and I'll clear the screen. You can instead specify the name of your node that you want debugging for. So in our case, it was called Hello World sub node. Now, if I run this, we only see the statements from our node. So when we get the subscriber message, we get a warning, debug, and error log message, all which are getting saved to a log file in our log folder. So I'll go ahead and stop this. So for now, I will mainly stick to printing information onto the screen with cout, just so that I don't have to worry about accumulating large log files. So I'll comment this out and go back to our old trusty cout print statement. So I'll be sure to save it and compile. If you want more information about logging, such as changing the directory of log files or doing functional debug statements, you can check out the ROS2 logging tutorial pages for more information. But with that, you now have a good introduction to using the logger to print information out to the terminal, which will also be saved to a log file so that you can view it at a later time.